while doing the paper airplane lab, you should have found that it does actually make a difference in the design of your paper airplane for how far it goes. If we look at the conclusion questions on the back, with number 4, with drawing the paper airplane, that can reveal to us why it matters what type of paper airplane you make. So, if we draw we have our person here with our paper airplane being thrown from here. Let's see, I'm not the best artist, but we'll see if we can do it at that. So we have our paper airplane. On number 4, it wants you to draw and label all of the forces acting on this paper airplane. And we want to do that with arrows. So we're going to draw an arrow going in that direction, because that's the way you throw it. So that's going to be your initial force. And that initial force came from your arm, you throwing the paper airplane. Now the second the airplane left your arm, other forces started acting upon it. First off, in the downward direction, we had gravity. And then since the paper airplane is moving through the air, it has friction in the form of air resistance. And if we have an initial force going in this right direction, then we would have an air resistance going in the opposite direction, because friction always occurs in the opposite direction of air resistance. Or friction always occurs in the opposite direction of motion, is what I meant to say. And so we know that friction always occurs in the opposite direction of motion. We also know that the paper airplane was being pulled down by gravity, which is another type of motion. Therefore, we had friction of air resistance also in the up direction. And then the last part of question number 4 says to draw a net force arrow. And so if we drew the net force, that means the general direction of the paper airplane after all the forces are applied. And so that would be this diagonal downwards direction for the net force. So we can see what's keeping it up then is air resistance, because gravity's pulling it down and your force is shooting it forward. That makes the net force in that downward diagonal direction. And some paper airplanes are able to stay up in the air longer than others, even though every airplane has this net force in that downward diagonal direction. That tells us that the difference is the air resistance. Sometimes the air resistance is higher on some paper airplanes and lower on others. And both air resistances make a difference in this. This upwards air resistance will be greater the more surface area that it is covering. And this in the left or against the forward direction air resistance will be greater or will make more effect depending on if it's able to go directly against the airplane, above the airplane, or below the airplane, depending on how you made your paper airplane. And the more the air resistance is forced to go underneath the paper airplane, the more lift it's going to have, and the longer it'll stay in the air. And so things that are really light that stay in the air long enough for longer amounts of time is because the air resistance is able to overcome the gravity force much more. And so if you haven't finished those conclusion questions from yesterday, make sure you do it today. And then on that last conclusion question, make sure you read through all 5 different points that I want you to answer, and make sure you're thorough in those answers.